Every living world, whether made of atoms or pixels, needs a mind. Not a single omniscient mind, but a network of smaller ones, each tuned to its surroundings, each quietly shaping the flow of events. That's the vision behind the Entropy Engine. A modular, self-organizing brain that reads the world's state, thinks in terms of entropy, and offers guidance to the agents within it. In this series, we explore how a single EE node can grow into a vast network, from one NPC's silent assistant to a planetary-scale intelligence, all while keeping human creators firmly in control. Over the course of these articles, you'll see how the EE wakes up, learns, and tempers its guidance to feel believable. How identical logic works at every scale, from a lone NPC to an entire civilization. Imagine turning on a brain. At first, nothing happens. It sits in the dark, forming connections with anything nearby. It reaches out blindly, linking to others like it, weaving a quiet web of relationships. No thoughts, no purpose, just structure. Then one day, the senses open. Data floods in. Not just random numbers, but the pulse of a living world. The slow churn of resources, the rhythm of day and night, the tremors of sudden events. At the core of the Entropy Engine is the most fundamental law in physics, the second law of thermodynamics. Every real system has entropy, a measure of disorder, and entropy always tends to increase over time. The EE doesn't care if your world is a medieval kingdom, a volcanic planet, or a candy-coated dreamscape. It only cares about how unstable the system is becoming. Every Entropy Engine listens in two directions. First, it listens upward, to its parent EE node if it has one. The parent might send gentle nudges like reduce activity slightly or prepare for resource scarcity. Second, it listens outward, to the environment itself. This is the telemetry feed. Temperature, population density, resource flow, queue lengths, danger levels, whatever the world happens to measure. Once the EE has those inputs, it runs them through its core logic. Mapping tables normalize the data. A sudden drop in river flow, a spike in temperature, or a surge in NPC density all translate to comparable entropy deltas. The EE's output is called a recommendation frame, a small packet of advice. This frame might include recommended work in progress cap, priority hints for certain types of tasks, emergency flags if instability is detected. Each EE node already knows how to talk to agents. In Eden mode, those agents are just empty chairs, placeholders in the roster. Now those chairs fill with actual NPCs. A single NPC chopping a tree might be a blip, but dozens? Hundreds? The tree population drops, resource availability shifts, maybe animals lose habitat, maybe other NPCs notice. The magic here is the closed loop. NPCs act on EE guidance, actions alter the environment, telemetry detects the change. EE recalculates, adjusting guidance. Repeat. If you could see this in a PET scan style visualization, it would look like pulses of activity moving through the network. Local bursts that merge into larger waves, then dissipate as balance is restored. Imagine you're an NPC in a farming village. Yesterday the EE told you to plant wheat. Today, it's screaming to abandon the fields and build fishing boats. Tomorrow it's back to wheat again. You'd stop listening. That's why the EE has built-in mechanisms to smooth its advice. Slew rate limits how quickly mode bias can change. Hysteresis band creates buffer zones around decision thresholds. Cooldown timers force minimum dwell time in each state. To an NPC and to the player watching them, this creates the sense that the world's brain is aware of trends, not just moments. Committed to its decisions for long enough to matter, quick to act when truly necessary. When you watch multiple tempered EE nodes in action, each with its own environment and agents, you notice something interesting. The network develops a personality. One region might be calm and methodical, another might be more reactive. Each EE node stores a simple, finite list of its agents. For each one it might track unique ID, current task count, last recommendation sent, acknowledgement status, recent performance. Without memory, the EE would treat every tick as if it had never seen this agent before. With memory, the EE can start to tailor its voice to each agent. An NPC who regularly ignores YP caps might get softer nudges. When you let this run for hours or days in a simulation, something subtle happens. The EE starts to remember not just agents, but situations. How quickly the world recovers from resource shortages, how often certain emergencies repeat. Interestingly, memory in the EE isn't permanent. Older data ages out automatically. This keeps the EE from clinging to outdated assumptions in a world that's constantly changing. Forecasting doesn't require mystical foresight. It's pattern recognition, spotting the same chain of events that led to trouble before, and estimating when it will happen again. A forecast frame might contain 2 layers of advice. Immediate guidance, slow production now to stabilize resource flow. Near future warning, expect scarcity in 12 to 15 ticks if trends continue. When NPCs appear to anticipate problems instead of simply reacting, the simulation gains a layer of believability. A farmer who plants before the drought feels wise. A city guard who patrols before the riot feels vigilant. Forecasting is not fortune-telling. The EE's forecast confidence depends on data richness, environmental volatility, and history depth. The EE can choose to withhold forecasts when confidence is low. An EE running inside one NPC is no different in terms of logic from an EE managing an entire city. Both take in telemetry, accept parent nudges, map to entropy units, calculate guidance, send it to their agents. What makes this fractal scaling work is that the EE doesn't actually know what kind of agents it has. From its perspective, an agent could be a single NPC, another EE node, or a subsystem running elsewhere. When an EE reports to its parent, it doesn't send the details of every agent. It sends aggregated metrics, total number of active agents, combined task counts, overall entropy level for its zone. A parent's guidance might be broad, reduce activity by 10%, and it's up to each child to translate that into specific actions for its agents. This keeps the higher levels from micromanaging. A self-organizing brain that can scale from a single node to a planetary network is thrilling. It's also dangerous. Not because it's malevolent, but because without boundaries, it can simply grow itself to death. The God Mode console exists to make sure that never happens. A minimal but effective control interface includes node count limit, agent capacity control, growth pause resume, node trimming, telemetry throttling, emergency shutdown. The console isn't just about levers, it's about situational awareness. At any time, it should be able to show total active nodes, total active agents, growth rate, CPU memory load by node, entropy trends across the network. The God Mode console is the handshake between the organic intelligence of the EE network and the human designers who run it. We'll give you the freedom to grow and adapt. You'll give us the ability to keep you safe. Eden Mode is the quiet before the storm. It's the moment when your Entropy Engine network is alive, connected, and sensing, but no NPCs are acting on its guidance yet. The world exists, the brain exists, but the body hasn't moved. We didn't design Eden Mode just to have a poetic garden stage. It's an essential testing ground for the network's core behavior before adding the complexity of agents. With no NPC activity, environmental telemetry changes slowly. The transition from Eden Mode to a living world is one of the most fascinating moments in an EE simulation. At first, NPCs connect like any other agent. Then they start acting. Environmental telemetry, once slow and steady, begins to spike and dip. Even after the network is live, you may want to keep an Eden Mode replica running in parallel. It's a perfect safe space for testing code changes, trying new network configurations, training new operators. While the EE's debut is in games and simulated worlds, its architecture is not limited to fantasy. Any environment with telemetry and agents could use it. Urban traffic systems, industrial automation, disaster simulation. The rules of entropy apply everywhere. In our mainline roadmap, the EE's first job is to keep the present balanced. But with enough history, it can start predicting the near future, warning of shortages before they arrive, encouraging preemptive actions, orchestrating long-term stability. With great scale comes great responsibility. When the EE moves beyond games into simulations that influence real-world decisions, questions arise. Who decides the tuning of its recommendations? How transparent should its reasoning be? We started this series with a humble idea. A little brain that takes in telemetry, thinks in entropy, and gives guidance to its agents. Along the way, that brain found siblings. Together, they formed villages, cities, and worlds. Whether you're a game designer, a simulation researcher, or simply curious about the future of adaptive virtual worlds, this series offers a step-by-step journey through the birth of a digital brain and the responsibilities that come with it.